All right, hi guys, welcome to the week 14 through 16 Start Here video. This is definitely supposed to be week 14 through 16. I decided to bundle up the final weeks together so that you have one module and you can work ahead and wrap things up early. So the good news is that most of our heavy lifting is behind us, and in this last couple of weeks you'll wrap up some of the ideas, and you'll also do some revisiting, some reviewing in the week 15 module, and so you can take your final exam as early as the date given in Canvas, which I will share with you in a moment. The last quiz is also in this module. This week the discussion board is on challenges with rational functions, and these last weeks are just kind of wrapping up ideas and putting it all together. I'll do a discussion board wrap-up, introduction to rational functions. And I just wanted to point out that big ticket number 2 grading is in progress, and I'll have those results back as soon as I get them done. So this is the final exam review that you'll find in the weeks 14 through 16 module in Canvas. And so your dates for taking this are Tuesday, December 6th, and no later than Wednesday, December 14th. So if you want to wrap everything up in the next week and a half and start preparing for the final exam, you can do so, and you can get it out of the way before the week of finals, if that may help you with perhaps other finals that you have, and working to try to balance things out. So hopefully that's helpful. Tuesday, December 6th is the first day, Wednesday, December 14th is the last, and here's information about the testing center. Keep all that stuff in mind as you go in and prepare to take that. So that brings us to the discussion board wrap-up. And here it is. So here we're dealing with rational functions, and the idea that in some cases we actually have ratios of quantity. So for example, if you're buying an appliance for $500 and you are going to pay, on average, this isn't going to be exact, but about $25 per year to run electricity on that unit, then you are actually, as you keep this thing longer, and the idea is that hopefully you're going to get your money's worth. So here we have a few questions. And let's see, what was I getting at? Oh, okay, so let's actually go through some of the computations, and what we're going to do here is just look at a couple of different average costs. So the average yearly cost for 1 year would be the total cost for that year, which would be the $500 for the appliance plus $25 for that full year of electricity. Now, we don't really need to divide it because we know it's for 1 year, but yeah, we do need to divide by the number of years. So we get $525 per that 1 year on average. Now, however, if we keep this thing for 2 years, then we're going to still pay the $500, but now we're going to pay two $25 a year electricity fees, right? That $25 for the first year, $25 for the second year. So that gives us $550 over the course of those 2 years. But now we're dividing by 2 years, and we get only $225 per year. Well, why is that? Well, let's think about this. So you're paying the $500 once, and then you're paying $25 each year. So hopefully as you keep this thing for a greater amount of time, that $500 that you paid for that appliance will get sort of averaged out across the years. And that's why a lot of people think that, if you buy something more expensive and it lasts you longer, then it's actually a cheaper yearly cost by the time you're done with that appliance and ready to move on to a new one. So let's look at it for one more quantity, average cost for 10 years. We'll pay the $500 plus 10 pay the $25 per year fee for the full 10 years, and then we have to average it out across the 10 years, which comes out to $575 for the full 10 years. Sorry, I think I have this wrong. So 500 plus 10 times 25 gives me $750, divided by 10 years gives me $75 a year. So now let's think about this in a more generic time period. So we have 1, 2, 10, and the thing that we notice here is that we divide, if it's for 1 year, we divide by 1 year and multiply the $25 by 1 year. If we do this for 2 years, we divide by 2 years and multiply 25 times 2. If we do this for 10 years, we divide by 10 years, multiply this by 10. And so if we do this for x years, that means we're going to divide by x years and multiply 25 by x, which gives us the function 500 plus 25x over x. So we can actually graph this and see what happens. And here along the horizontal axis, we see that we have time. which is measured in years. And then over here we have the average yearly cost, or the dollars per year, for having kept it that long. So if we keep it for 60 years, for example, right here, that's going to correspond to an average cost of somewhere in the vicinity of about, let's see, that's 2040, about $40 per year. So why is this happening? Well, again, we have the function 500 plus 25x over x. Now, one of the things we know about fractions is that whenever we add fractions, that this tells us the number of copies of the fraction that we have. So, if we take, for example, something like 1/3 or 1/5, let's say, plus 2/5, then, well, that means we have a total of 3/5, or 1 plus 2 over 5. So similarly, we can go from taking a fraction and decomposing it back into two separate fractions, which is what we've done here. Now, why are we doing that? Well, it turns out that now you have 25x over x, so those x's cancel each other out, and so that leaves us with 500 over x plus 25. Now we need to make an argument here. As x gets really big, what happens to this? Well, if you take 500 and you divide it by a larger and larger and larger number, then this fraction will become smaller and smaller and smaller. It'll approach 0. So that means that regardless of what x is, this 25 doesn't change. It doesn't depend on x. So as x gets really, really big, this term approaches 0, and that means 0 plus 25 means that we expect in the long run to be paying $25 per year. Why does this make sense? Well, eventually, if you average out the $500 over, let's say, infinitely many years, which doesn't make sense because we know we don't keep appliances that long, but if we would, then essentially that appliance would get averaged out to the point where it costs almost nothing per year, but still, you're always paying $25 per year because of the appliance electrical fee. So no matter what, no matter how much the appliance costs, you're going to be restricted by the maintenance, the electricity fee for that appliance. Which also brings up another point, that if you are buying an appliance that, oftentimes pricier appliances can have better Energy Star ratings, which means that if you can get this down to like $10, it might actually be worth it because you're saving the $15 a month that you'd be paying for this $500 appliance. So just some things to think about. So hopefully this has been helpful. And and this is also, by the way, why now you're learning about vertical and horizontal asymptotes. And the horizontal asymptote we've found by taking the coefficient of x, or the largest powered variable here, and dividing it by this coefficient, which is 25 over 1, or just 25. And that's where that asymptote comes from, mainly because of all this mathematics that can be done that takes place here. So have a great final weeks. Feel free to reach out if you have any questions, and I look forward to seeing you in the final discussion board. Take care.